Hey guys, welcome back. Now in today's video, we are going to understand as how to navigate through the data frame. Now the first question is, what is a data frame? So a data frame is a two-dimensional structure of data. So if I represent it in a format as a visually, so this is how a data frame looks like. So it has the rows and columns arrangement of data, guys. And the best part of this data frame is this, as you know already, this is a data frame which is available inside this Pandas library. And the best part is it can store the data of various data type. That means I can have one column belong to the data type of strings. I can have another column belong to the integers, complex numbers, boolean, and so on. That means I can have a data which belongs to the various data types, and those data types would still be valid when we are performing the analysis on the data. Now that's the advantage over the NumPy arrays, guys. And the another thing is this data frame, you can think of it as an Python version of Excel sheet. So in an Excel sheet, we'll have a column name and we'll also have the row name. So in the same way, for my data frame, I have my index label and I'll also have my column label. Okay, now if this is my data frame, let's say I have my index labels as customer ID, customer name, customer age, gender, and quantity, and price paid. So if these are the various columns that I'm having, then I have the row names which says as customer name. So Harry, John, Jacob. So these are the row names. So these row names we call it as index labels, and these column names we call it as column labels. Now one of the common requirement that we'll be having when we are working with this data frame object is I want to retrieve a single object from this data frame. Now let's say this is a single object which I'm interested in retrieving from this data frame. Now if I want to retrieve this single object, I have two options, guys. This is important. I have two options. One, I can specify its index position. Okay, I can specify its index position and get this required value, or the another option is I can specify my index labels as well. Now just to give an example over here, so if I'm referring to this index position, so even in case of Pandas data frame, the indexing starts with 0. So 0, 1, 2, 3, 4. Column names are 0, 1, 2, 3, 4. So these are the various column IDs that we have. Now if I want to retrieve this value, then in such scenarios, I can specify its index position, that is 2, 0, 1, 2, 3. Okay, or I can specify its index labels, Jacob, and this is gender. Okay, so in this way, we can get the required entry from our data frame. So let's do one thing. Let's create the data frame, and let's see how we can create the data frame as well using the sklearn datasets. And after we create the dataset, let's perform the indexing and let's navigate through our dataset that we have just created. All right, so let's get started, guys. I'll start by importing my Pandas library. I'm going to say it as import Pandas as PD, and I'll also import NumPy as NP as well to make sure that I have all the necessary things. Okay, now this time let's load the data set, and I'm going to load this breast cancer data set. Okay, so let me just click on this. So this is what it says. I am going to say it as from sklearn.datasets import load breast cancer, and I'll say cancer is equal to load breast cancer. Okay, so this is going to load this breast cancer data set, which is a Wisconsin data set. Now let's see. So what have I given? I have the option as XY as false. That means whether I should return the X and Y separately. Now I don't want that, so I have just imported everything inside this data bunch of cancer. Now if I say type of cancer, so it's a data bunch, guys. Now let's go ahead and separate our input data, output data, as well as the feature names. So I'll say X is equal to cancer.data, Y is equal to cancer.target, okay, and I'll say features is equal to cancer dot features and underscore names. Perfect. Now once this is complete, let's go ahead and build the data frame. Hey guys, if you're not aware of how to make use of this sklearn datasets library where we can create our own dataset, do check out the link in description. We have already spoken about in detail as what are the various ways that you can actually get the dataset from sklearn library. Okay, now let me create my data frame. Df is equal to pd dot data frame, and I'm going to say it as my x, which is my data, and I'm going to say it as column names is equal to features. Okay, I'll say df dot head. So this is how my data frame looks like. So I have various data, that is mean radius, mean texture, mean perimeter, mean area. So these are the various columns that we have in this data frame, and these are the index labels. Okay, so let me just take a scenario and see how we can get that specific entry. Now let's say I'm interested in picking up this value, that is mean symmetry column, and the index label as 1. So remember guys, these values that you're seeing over here 0, 1, 2, 3, 4, so these are my index labels. Okay, so these are my index labels, and these ones are my column names. Okay, now if I want to perform the indexing by referring its index label as well as its column label, in such scenarios we'll say it as DataFrame dot log, and then inside the indexing operator we specify our index label and column label. Okay, that is how we actually perform the indexing when we are working with data frame. So let's do one thing. Since I'm interested in picking up this data, the value is 0.1812. Let me go ahead and do that. df.log, and I'll say 1 because that's an integer, and then the column name is this one, mean symmetry. Perfect. Now I'll just execute this and let's see what will be the output. Okay. Perfect. I have the output as 0.1812. Now this proves that if I want to navigate in my data frame and get the required entries, I have the one option, that is by specifying its index label as well as my column label. Okay, now let's do one thing. This time let's make use of the concept of index position. Now in this case, along the rows, the index position is same as my index label because I have actually taken my default index position. So let's do one thing. This time I'm going to say it as df, and guys, this is very important. When you want to pick up something by referring its index position, in such scenarios we make use of .ilog, that is df.ilog. Now this time I'll say df.ilog, and index position is 1 and column label is 0, 1, 2, 3, 4, 5, 6, 7, 8. So this is at 8th index along the columns. See, I still have the same output like before, 0.1812. Okay, so this is how I can navigate my data frame, guys. And once we load the data in the data frame, one of the common functions that we normally do, that's called as calling the describe method. Now if I say df.describe, observe the output, guys. This is very important when it comes to analysis of the data. Now when I call this describe, so this is actually giving many important information. So the first important information is count. So how many number of rows that I have over here in each column. So in each column I'm having 569 rows. And what is the average of individual column? What is the standard deviation? As you know already, standard deviation tells me as how far it is away from my mean. So what is the standard deviation? And what is the minimum value over here? And what is the maximum value? So minimum value and the maximum value helps me to understand the spread of my data. So how far the spread is, or how closer the spread is. To get that information, we can make use of this minimum and the maximum. And to identify the outliers in my data set, so it is also giving me the information of Q1, Q2 and Q3. So these are the various information that I'm getting as a result of calling this df.describe, which is a single method. Now using this data, you can clearly make out, just to give you an example, here for the column of pin radius, on an average, the mean radius is 14.127 and the minimum value is 6.981 and the maximum value is 28.11. So that means there's a lot of spreads in the data from the average. And we could see the standard deviation is 3.52. Okay. And there can be a scenario, guys, where my minimum value is 0 and my maximum value, let's say 2000. Now just imagine this, if you have this much varying scale, now imagine what would happen to the standard deviation. Yes, obviously in such scenarios, the standard deviation will be very high. And when that is very high, you'll think about it and say it as, okay, so my standard deviation is very high for this data. Now let me look into the median of the data. Median is the center point when it is sorted. So it is going to look into the median of the data and we'll see, okay, so this is my median, but this is how my minimum value and maximum value is present. Let me look into the Q1 and Q3 and measure whether these two ones are outliers are in the data. Now that is how we can make use of this numerical output that we are getting over here from this df.describe method, guys. Okay, now in today's video, we have understood as how to create a data frame and how to navigate the data frame and get the required part from my data frame, guys. So as we progress in this learning journey of tips and tricks for data scientists, in future, we'll also look into the advanced functionalities that we have, which will help us to perform the filtering on my data frame. So we'll see everything as we progress in our learning journey. So if you're new to us, please consider subscribing. I look forward to seeing you next time. Till then, take care, guys.